Happy day, YouTube. My name is John, and this is my channel, The Intermancer. On the last episode of this journey, where I'm generating a genetic algorithm framework, I started describing a couple of new classes of genes. Previously, I had only implemented very simple arithmetic genes that basically worked on constants, and that's why I wasn't getting a whole lot of biodiversity and the genes that were in the organisms that were generated through the course of an experiment. So I decided I needed to add more genes so that we can increase the complexity. I said that at the end of last episode, I said that this episode we would implement those genes, but I thought of at least one more thing that needs to be taken care of, where I have one more class of genes that I want to add. And so we're going to do that first. If that happens quickly, then we'll move right into implementation. One thing of note is, for now, until I get to the point where I'm implementing, I'm working in the same chat that I worked on before. I've since quit and restarted IntelliJ, so I had to go back to this chat. There's, I think, a certain art in deciding when to start a new chat. A lot of people will say that you should just have one chat going the whole time with a big context. Obviously, with some LLMs, that's easier than others. I personally think that one of the strengths of this approach, where I describe the context of the application in separate files, is that I can more readily start new chats and have them focused on implementing particular new features. That's what we're going to do here. So starting with a context-driven approach, the first thing I'm going to do is describe the category of genes that I want to implement and ask the agent to expand that, and we will incorporate the descriptions of the genes that it comes up with into the context file, and then we'll get it to implement all of the genes that it's come up with. We have one more category of genes to describe before we begin implementation. Control genes will use data points to control the flow of information. Control and modify. For example, a limiting gene will output a channel that limits the maximum value of a channel based on the value of a second channel. Limits the minimum or maximum. A switching gene will output one channel or another based on a threshold value of a third channel. Put a data point second data point, data point. Data point. Come up with some suggestions for control genes. But do not implement anything yet. All right. All right, control genes are the first category that naturally requires 3 indices. Let's look at the ones it has. Clamp gene. Okay, threshold switch. Absolute reads value and gate out. Scaled blend gate, 2 values and a blend weight, computes a weighted average using result. Okay, that's interesting. Unlike fixed the mix ratio is itself data. Okay. Reads 1 data point and a constant. Outputs plus constant is I don't know about that. Sign gene. Outputs plus constant if the value minus constant if and 0. Okay. Okay. I got it. Magnitude gate and the sign gene. So the sign gene just outputs 1 of 3 values, either plus constant, negative constant, or 0, based on the directional signal. And that'll be more valuable since we've added these other genes that will, a lot of the signals a lot of the data points will vary more, and we expect some more variability. Magnitude reads a value, and then magnitude multiplies the value by the sign of effectively a polarity. It lets a downstream gene invert a signal conditionally based on market direction. Okay. Reads 2 data bounded scale, a value and a scale factor, multiplies them but clamps the scale factor to a constant range before applying it. Prevents a runaway scale value from producing extreme outputs, which is useful when the scale channel may carry noise or unbounded data. Okay, sure. Select max gene, select min gene. Reads 2. No constant needed, simple but powerful as a building block on order. Okay. Go ahead and add descriptions of all of these genes to basic genes.md in a new section called control genes. And while it's doing that, I want to look at the gene generator. Okay. So the gene generator has a block here. Okay, basic genes. Let's look at that. Make sure it did it the way we want it to. Does it do new sub packages for didn't add a sub package for window genes, so I don't know why it needs one for control. Alternatively, I see that you added a new package for the control genes, but not for the window genes. Go ahead and add a, so this would be guide core organism gene control, gene basic package for window genes in basic genes.md before implementing anything. And while it's doing that, I want to test to see, I want to see if it has test classes for the basic genes. It does, so we'll go ahead and add test classes. 32. Yes, do that. Okay, now I'm going to go ahead and continue on. This is exciting. This might end up being a little bit longer video because I'm going to move on to implementation. And this is actually going to be a fairly large implementation because I've described several gene classes. And it's going to implement all of those and test code for all of those. Let's move on to implementation. Implement all of the genes described in basic genes.md along with their test classes Also modify gene generator .java to include the new genes. $5 just for the thinking there. This should take a while. 9 to-dos. I'm surprised it didn't take longer than that. And parallel batches. Oh, warming cycles. I have to add that to the experiment cycle. Okay. It's adding data points, multi-data point genes. Adding them to the right place, that's good. I think I need to check because on division it says it'll throw an exception. And I don't know that I want that behavior. If it does divide by 0, I want it to just output 0 rather than throw an exception, because that seems to make more sense. I want it to be a little bit more robust. So I'm going to check on that at some point here. Maybe I forget about it and I just remember it if I see it show up in an experiment run. Gene window. Good. Hasn't done any of the tests yet. This is going to make the system much more interesting. I'm really looking forward to the first successful experiment after all of these genes are added. Hopefully we'll see a lot more diversity in the scores. And at this level, that's what I'm going for. I'm going for diversity. I don't really care so much about having a system that does a good job with predicting. I know that's counterintuitive, but right now, the thing I have to worry about at this point in development is just the biodiversity itself. You can see this is a lot of code. I think that this is the most code I've asked it to write in one run since I've started this whole project. So this is a little exciting. And I guess this is also one of the values of doing it with an agent and having the agent be able to refer to a context file. So this is kind of putting to test my philosophy on how I'm approaching all of this. Update gene generator. So remember, I didn't read it out loud, but the gene generator has two sections. One where it selects the gene to generate, and another section where it sets all of the default channel values. So we're going to have to check all of that. Test classes. So this is going to be a lot. Now write all window gene tests in parallel. I don't know what it means about in parallel. It looks like it's doing it serially. Costs are climbing, but nothing big, huge right now, especially considering the sheer volume of code that we're looking at. I wonder why some of the write tasks have a check next to them and some of them don't. I don't want to go look at the code yet while it's working. If I was getting paid to do this, if this was my job and not just my hobby, then I would spend a significant amount of time making sure I put eyes on all of the code that was getting generated. At least just to look at it as a sanity check. What I'm going to end up doing after it runs is spot checking a few of these. I'm not going to check all of it. Like I said, I'm more excited to getting to that first experimental run to see what kind of diversity it creates. So it looks like it may have finished all of that. What's it doing now? Okay. All failures in gene generator test. It's rerunning all of the build. Distribution test. Wow. So that's great, having the test code here, even though I haven't written much of it. So there's an idea in your coding. When we used to have to generate all of our test code, the idea of having a bunch of test code is that you never know where problems crop up. And so the test code is like having another check on your code, both in the functionality that you need, and also just functionality that's there, because exercising your code in a broad way is always useful. And so what just happened, it detected a problem where one of the genes was never going to get generated, came out because it had a distribution test. Okay, so that's a lot. We still need to incorporate warming cycles into the experiment process. Analyze experimentation.md experimentation to and figure out where warming what changes are necessary to incorporate warming cycles. Here is the analysis. Okay. Okay, so effective, okay. All right. Go ahead and implement all of these changes. Okay, he's looking at the test. I'm seeing that normalized score is dividing by 4. It's only 7 minus 3. Okay, if there was like 200, it'd be 200 minus 3 versus 200 minus 7 or whatever. Okay, I think that's fine. Biometer test. This is exciting. We are adding a lot of code. This is easily the largest code change I've made in one pop. Oddly enough, not the most expensive though. The cycle where I was making all of those changes to the UI was more expensive. So far, all of this is costing me $5.08. Okay, it looks like we're all done. So we are going to do a build now and see what it looks like. That was fast. That was surprisingly fast. So we will now run it. All right, that's the back end going. Front end's going. Site's coming up. Start an experiment. Oh, experiment error. What happened? Let's see. Division by 0. Okay. Change all of the division genes so that they do not throw an exception. If divide by 0 is detected, merely output 0. So that's not really mathematically legitimate, obviously. However, it is what we are going to do to just keep things flowing. A lot of times when you do analysis tasks, you have conventions that you follow. So we are hard coding a convention here. It's updating the tests. That's good. 4 files change and it outputs 5 files. Lovely. All right, back to this. Let's do a clean build. Let's run it. Start the front end. Start an experiment. All right, it's going this time. Ran pretty fast. Let's go to the repository. Look at this. Look at this. Everyone is different. The scores are a lot lower. That's that normalization that it was talking about. But the thing that we care about here is that every score is different. Let's just go ahead and look at our winner. Addition, sign, multiplication, absolute value, select min, select max, addition, addition. That is lovely. Threshold switch, addition, addition, select max, addition, addition. Data point division, data point addition, 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 addition. So the winners aren't very complicated. Addition, addition, select min, select max, addition, addition. I'm going to do something wacky here. I'm going to try a 5,000 cycle experiment and see what happens. It's running pretty fast. That is nice. Already done. Already done. Huh. It only has one experiment. I ran a second experiment, but it looks like the repository view in the UI only showed me the first experiment. That's different. I know the first time I ran multiple experiments, it showed me all of the experiments. So I'm going to try to get this part fixed, and then we'll see if it takes long. I want to check out experiment controller. This, get all experiments. So fetch, okay. Let's see, I still have the back end running. Increments. Okay, all of that is changed, so now I should be able to reload this, and the repository still only showing one. So let's go ahead and restart the back end and the UI. Do another default experiment. It should run through real fast. Already done. We see that in the repository, 1140, that's one that just ran, 1140. Now let's do a new one. Again, I will try a bigger one. Still runs pretty fast. Still not showing up. Restarted both the back end and the front end. I ran 2 experiments. I'm still only seeing the first experiment on the repository screen. The error was not fixed. I'm going to have to read all of this. 45 minutes. As soon as this is done generating, I'm going to go ahead and stop the video. I'll start the next video with reading this and trying to get this to run successfully. Okay. Wait a second. Okay, so it found an unrelated bug in the course of doing this. All right. Should I? Let's go ahead and rebuild everything. Because if this works, then that's a better place to stop the video. Start up the back end. Start up the front end. Repository has nothing. Do an experiment. Confirm the repository has one at 11:45 and 45 seconds. Do another longer experiment. Now check the repository. Still not showing up. Still not showing up. Even when I restarted at 45:45. Okay. We're going to stop the video here. And the next video will be debugging the UI. And that will be interesting because I do not have a lot of experience debugging a React application. And that's exactly what we'll be doing. So I appreciate your time, and I look forward to the next one.